this is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 5-1 in the SavvasRealize Algebra 2 textbook. Today's video is about understanding rational exponents. So first, let's start with defining a rational exponent. When we say rational, what we're talking about is exponents that are fractions. Alright, so like you see here, all of our exponents that we'll be dealing with today have a fraction up here. And it behaves very similarly to normal exponents, right? So if I have like x to the 1/2 times x to the 1/2, I still get x to the first power because you can still add the exponents, all right? So our properties of exponents still apply, but when we have this fraction here, it gives us another property, and it's this one right here. All right. Whenever we have a denominator to our exponent, what it does is it creates what's called that nth root. Okay, we learned about nth roots in example 1. And so that nth root allows us to start breaking down the numbers a little bit further. Okay, that's all that we're doing with these. Now, one thing that's really cool about this is you can see there's two expressions here about where they're putting the numerator of the fraction. All right, we could put it on the outside, depending on if that nth root is easy to solve, or we could put it on the inside to help us break it down even further. All right, so kind of depending on what's going on, one or more, like one of these might be more useful than the other. Alrighty, so let's look at example A here. Alright, so it says, what is the meaning of the exponent in the expression 16 to the 1/4? Alright, so if I go to write it out like we have there, right, I have my root symbol. Now my base here of my term becomes the radicand, so I'm going to put the 16 on the inside here. The numerator of the fraction turns into an exponent for this inside. So I'm going to put that 1 there. We don't really need to say 16 to the first, right? Because 16 to the first is just 16. But I'll put it there for now. And then the 4, which is the denominator of the fraction, comes out here outside of the radical. So the meaning of the exponent is saying that we're looking for the 4th root of 16. Now, if we go to evaluate that 4th root of 16, just so you know, you actually end up getting 2 numbers, which is kind of neat. So let's look at part B. So part B, all right, our radicand is 27 because that's the base. The 3 is the denominator, so it comes out here as the index. And our 2 is the exponent. Now, if I were to evaluate this, okay, I would not be putting this 2 in here. The reason why is I know that 27 is 3 times 3 times 3. Right? So the cube root of 27 is 3. So what I would do is I would actually end up writing this like this, where that 2 is on the outside. Because we can call that cube root of 27, we could call that 3 cubed. Or I'm sorry, not 3 cubed, just 3. Cube root of 27 is 3. And then we can square it. So 27 to the 2/3 is actually 9. The 4th root of 16, right? 16 is 2 times 2 times 2 times 2. So the 4th root of 16 is 2. But if those were all negative 2's, negative 2, negative 2, negative 2, negative 2, I'd also get a positive 16. So we have that negative part here. So anytime you have an even exponent, you want to see if negatives work as well. All right, let's try these ones. All right, now It says, which of the following is not a possible root or equivalent expression? I think your try it's called the instructions a little different, but I wanted to kind of show you some stuff here. Now 25 to the 1/2. Okay, we know that that's the same thing as the square root of 25, right? Because the 2 would come out here as the index and the 1 would come here as a power. And you don't really have to show either of those. Now I could evaluate that root, right? The square root of 25 is 5 and -5. But just don't let yourself forget. Like some people get all trapped up in there needs to be a positive, there needs to be a negative, and they'll forget that there's a they'll put a negative here inside the root symbol. You only put the negative once you've evaluated the root. All right, so that is not correct. So now let's check out this one. So 32 to the 2/5, right? This is following that same formula, right, where the 5 turns into the index and the 2 turns into the power. So this one's good. Now 32 squared is 1024. All right, so I could square that 32 and then have the 5th root here. It's a little ugly, but we can do it. And if we actually evaluate it, all right, the 5th root of 32 is 2, so this is 2 squared, which is 4. In this case with the diamond, they put the bottom of the fraction in the wrong spot. It should be the index, so that's why this one's not correct. So there we have it. That is example 2. Until next time.